Hi, this will be our last part of our rational function mini lecture, and this one actually will have an oblique asymptote, and its function is x squared minus 2x plus 1 over x plus 3. Now the first thing I'm going to do is I'm going to try to factor it, x minus 1 squared on top and x plus 3 on the bottom. There are no common factors, so there won't be any holes in this problem. And like we did on part 4 had a hole in it. This one will not because there's no common factors. So the first thing we're going to do is find the x and y intercepts. So x-intercept, we set the numerator equal to 0. So x minus 1 squared equals 0, so x equals 1. So we draw our graph. So x equals 1, there is an x-intercept. Okay? Now on this one, it's got an even degree. We haven't done one of these that didn't cross. They always seem to be crossing on the x-intercept. I made this one on purpose to actually bounce. So this one actually bounces off, or touches and goes the other direction. So I use bounce a lot in my traditional classes. I think the book uses like T for touching and then turns the direction, the other direction. So now y-intercept is you set all the x's equal to 0. So if you let all the x's be equal to 0, it'd be 0 squared minus 2 times 0 plus 1 over 0 plus 3. So it just turns out to be y equals 1/3, which is just barely above the origin. So it's right there. So those are your intercepts. Now this particular problem, the degree on top is 2 and the bottom degree is 1. So there will not be a horizontal asymptote on this one. Remember I said a while ago though, I said if there's a horizontal asymptote, you will not have an oblique, and conversely. So if you have one, you won't have the other, in other words. So in this case, you will not have a horizontal asymptote. So this one doesn't give you one. Now the vertical asymptote is setting the denominator equal to 0. And that just finds all your domain errors. So all the ones that will not be allowed to be put into this function. And in this case, x equals -3. All right. So now, -3 is your vertical asymptote. Now, does it cross the horizontal? Well, it can't cross the horizontal asymptote because you don't have a horizontal asymptote to cross. So if you don't have an HA, then you don't have to worry about C either. So they go together. So this one you will not have. Now the oblique asymptote, here's this problem I said, most of the problems that you're going to have, over 90% of the problems that you're going to see will not have an oblique. There is that 5%, and here's one of them. So this one on top is degree 2 and the bottom is degree 1. So you have to find the oblique asymptote. And I'm going to just show you the most direct way of getting there. So what you do is you do it by long division. You divide x plus 3 into the numerator, which is x squared minus 2x plus 1. And the oblique asymptote will be the quotient minus the remainder. So you don't have the remainder at all. So divide x into x squared, it goes in x amount of times. So x times x is x squared. And then x times 3 is 3x. So just like long division. And then you subtract. So x squared minus x squared goes away. And then -2x minus 3x is a -5x. And then bring down your next number, just like regular long division. And then x will go into -5x -5 times. So -5 times x is -5x. -5 times 3 is -15. And then you subtract that. There's a remainder, but we don't really care about the remainder. The oblique asymptote is just the quotient. So the y equals x minus 5. And some people call these oblique asymptotes slant asymptotes. And you'll see why in a second, because I got a graph y equals x minus 5. And it's going to be a dotted line. If you graph that, it has a y-intercept of -5 and a slope of 1. So the oblique asymptote will kind of look like this, which is basically the equation, the graph of y equals x minus 5. So it slants. So it's not like the horizontal asymptote. It's like a horizontal asymptote without the slope of 0, because that's what a horizontal asymptote has, is a slope of 0. This one's got a slope of 1. So now, remember the graph bounced off of this point. So right here, it comes up and bounces off of that. And where does it go? It goes for the oblique asymptote. And then it goes to the other side. And it can't come back down because there's no x-intercepts between -3 and 0, so it's just got to go up. So it ended positive. So on this side, it's got to start negative. And so it's just kind of compartmentalized over in this little section right here. So it starts ended in positive, so it starts negative down here. And so it just twists back around and follows the oblique asymptote down in the third quadrant. So it's kind of an odd shape. But the thing about it is, it's probably not the best picture in the world, but because it probably does more like this. But I don't claim to be the best artist in the world. So it comes up through like that, and it ends positive like that, and then it starts negative up on the other side. So a lot of people get confused with this because it looks like a whole big section missing, and it's not. There's not a whole piece section over here of this graph missing, because this graph actually, you just don't see it. It just blooms out down here. So this thing gets going out this way. This part keeps coming down this way. So it's a huge graph. You just don't see very much of it right here. And all the domain is covered except for the -3. So because if you're over here on this axis right here, if you're standing right here, you do see the graph. You don't see it up here because it looks like it's all vacant. But if you look straight down, there is part of the graph down here. And if you keep walking along here, it's still down there. So, but this is the oblique asymptote. You don't see very many of them. Like I said, it's not traditional classes, won't see much of them at all. The online classes will probably see a little bit more of them than you guys do. So, but this is part 5 of our mini lecture, and that will conclude this mini lecture. So, is this everything on rational functions? No way, no way. There's a lot more to it than this. I'm showing you probably 80%. This is still going to be 20% that, I've showed you all the main cases, but there are always exceptions, and you just have to cross those bridges when you get to them. So that's it.